So we know that we have an environment, we have an agent. So agent is myself who I'm started to learn to drive. So from that point, each and every action that I perform is basically based on the state currently I am in. If I'm going too fast, if I'm going too slow, if there's a stone or obstacle somewhere in front of me, based on that, I will get rewards or punishments. Okay, all of these things, I hope we are able to correlate with the example of us, even the time when we are learned how to drive. Okay, so there are few points that are really which are to be added for these reinforcement learning. As I told, learning about the stimuli in the sense each and every action that each and every state that we get. Okay, so and based upon that, the actions that we perform, okay, in turn they are related toward the rewards or the punishments that we get. Rewards are like applause. Somebody will tell me like, okay, yes, you have done very good, you have started to drive very well, that's really nice. Okay, and if not, you would get a punishment. I've already told you that. Okay, so also one more important point is like there's no detailed supervision available. Okay, see, your parent will be with you only once or twice as long as they feel that confidence in you. It's not all the time they are along with you. Okay, so there is no major supervision that will be done with reinforcement learning. Initially, for the first time also, when you started, okay, there will be someone holding you. But the time when you get to know the control of it, you yourself would have learned so many things after it. Even when you're driving your four-wheeler as well, okay, how many ever times, like most of the time in the highway, you're not supposed to apply the brake as until and unless there's a vehicle in front of you, right? And if you're joining into a highway, you have to know, make sure that there's no vehicle which is coming as fast as yours or more than yours. You're not suddenly allowed to go in front of them, right? Because if there's a bus in front of you, when he applies brake, basically you don't know what's happening in front of the bus. So you actually drive it accordingly to what your front vehicle is going ahead. And when a speed breaker is there, you basically observe is if it is a far vision of yours, it's like you immediately don't know that there's a speed breaker over there until and unless your front vehicle applies a brake. Based on the lights, you will identify, yes, there's a speed breaker, probably that's why he's applying a brake, let me also apply. So that is how basically the driving also works ahead, right? So in that case, okay, there's no detailed supervision with respect to reinforcement learning, in the sense that each and every micromanagement, I can tell that like this, every micromanagement, every step, everything that we perform, right? The target minus of predicted, we take the error difference, we apply the weights, we come up with the gradient descent change. No, that procedure is completely delayed here. You do not have that complete supervision done by anyone here. Okay, so there's a huge difference with the supervised as well as here the reinforcement learning. There's no supervisor over there. Okay, the machine itself, it will try to learn each and every instance, it will try to come up, it will let you know what it has to do. Okay, so no detailed supervision available. Trial and error learning, yes, we know it's basically the trial and error learning that it goes ahead. And then you have delayed rewards. It's not always the first time you get an applause. Your parents also will be waiting to tell you, okay, let him learn well and then let's give him applaud. He'll get overconfident on himself, right? There are certain situations that would have happened also. Even in reinforcement learning, as long as it goes ahead with much number of trials, reinforcement learning will not immediately tell you, okay, you have done a better work. No, reinforcement learning is like you will have thousands and millions of policies that it will train each and every time. It will try to make sure that it is completely better. There was one similar experiment which was being conducted by IBM. I remember this when I was reading my stuff. So an IBM researcher, okay, when he was trying to play chess, he tried to build up a system, okay, where the first go, the system, a human is going to work in front of a system, like the first interaction is going to be the human with the system. Okay, and when that has been performed everything, it will keep the record of all of it was basically again a trial and error method. He had all of his data entries that was being done by the human. Okay, later he himself, okay, he took away that he was not a participant in it. He made the system to be the participant next, against a system. You're getting this point? The first time when a researcher tried doing it, okay, he started playing with the system on a chess game. Okay, so all of the instances, all of the moves that he made was recorded by the system. The second trial of it, the system was a player rather than the person himself. The system was a player against a system. There was thousands of experiment which was being performed from a system to a system. Okay, so in the sense, one after the other, they used to inter-exchange. They used to learn around 1,000 experiments continuously performing one after the other, one after the other. There were so many instances which later came up with like a complete overall automated chess game. So it's like every move that we think, as I told you, you have to think one step ahead of. If I'm doing some move here, what will the other opponent of mine will think? That is basically how a chess game works. The similar, even the system was trained so, with more than 1,000 experiments, one after the other, working beside the systems, like two systems on in hand working. Okay, so as I told, the responses or what the rewards you would not immediately get out of it, it is after a delayed process. Okay, so that is about the delayed rewards. Sequence of actions required to obtain the reward. Yes, as I told you, you need to have that sequence of actions that you have to perform. So only when the sequence of actions is performed, only then you would really get to know that, yes, your reinforcement learning system that you're coming up with is able to go ahead with. Even us, we would also have learned the sequence of learning, right? One step after the other, how to drive a car. Yes, first you'll have the three options, the brake, accelerate, the ABC. And you have the gear system where you have 1 to 6 or 1 to 5 in certain systems. If you're going ahead with an automated driving system, it's basically you only have the drive option and you have the reverse option. So you don't have the gear, you need not work ahead with the gear. So you just go ahead in the drive, yes, in the drive mode with the accelerator on, the reverse mode with the accelerator on. So you go ahead and it's easy for you to go, right? So, but still there are certain steps that you have to follow. If you do not have that sequence of procedures followed, what would happen? The point of time when you have to put your brake, you go ahead with your accelerator. Instances are difficult, right? So everything that you perform is going to be in the form of a sequence. We already know that in our day-to-day activities. I know many of you drive your vehicles, in the sense your two-wheeler or a four-wheeler, a bicycle. We do that. Bicycle now has become something with respect to what you call uh, fitness freaks, right? Initially, bicycles were a mode of transport at that point of time, but now bicycles are for fitness freaks. Yes? Do you agree? No? Okay. So we have associative learning required. Associative learning is okay, from one to the other, there should be certain mechanisms that we perform. One step, when I tell, okay, when I apply a brake, okay, when I have to apply the gear, okay, I want to go ahead with the first gear, applying the first gear. There's a procedure in the sense I have to first put my brake, my gear, for the gear, I have to completely have my clutch on. So I have to give my clutch on and only then change my gear, right? So that's basically how you go ahead with. So it is associated. When I have to change my gear, the main important part is I have to apply my clutch and only change my gear. So there's an association between applying gear to applying clutch. So even in reinforcement learning, yes, you have a lot of associations with respect to learning. Okay. And learn about policies, not just actions. Okay. Actions, we know how we have to perform. It's not just only actions. You really need to know certain policies associated with it. In the sense, action is basically when a vehicle is coming in front of me, applying brake is an action. Okay. But a policy is, what in case, at what time should I apply the brake? Okay. So when I apply that brake, what is my next appropriate action or appropriate instance that will happen? Okay. If in the sense, if not, I did not have anything which is coming in front of me, but still I need to take an action applying brake if I have to stop it. It's not that only when there's a vehicle which is coming into it, I have to apply the brake, but there are other instances also that I have to apply brake. So you need to know those policies and association, or what are the other instances along with just a vehicle coming in front of me. Apart from that, what are the other instances also where I might need to apply the brake? Not just only one action, but it has to be a certain set of policies together. And it's a lifelong learning. Reinforcement learning is a lifelong learning. As I told you, there is no point in time. See, you're trying to come up, you're trying to make something like our human brain. Reinforcement learning is completely like a biological system, how our human brain thinks. You know, human brain is so complicated that it has senses to perform everything. If someone just comes and taps at the back of you, just taps at the back of you, immediately you'll just turn behind and say, who's that? The senses is very sharp with the human brain. A similar analogy, if you have to try coming up with, there are a lot of policies or lot of actions or states that you have to build up. That test case building a test case itself is something very difficult with reinforcement learning. In the sense, it takes a lot of time for that. You have to create it manually. Basically, that is how even today researchers are going ahead, creating manual testings or creating manual test data for that. So it's actually huge. Getting the data set itself for reinforcement learning is something very crucial. Okay, so I think I'll stop here for today. Okay, I'll just give Sandeep a little time and I'll take the attendance. So you guys can let me know if you have any doubts.